Welcome everybody to our Lunchtime seminar. I'm very proud to be here today to introduce you to our latest product. But today we're actually not only launching a new product, we're pushing the boundaries of our service to science. Our vision at DECTRIS has always been to help you to do your research faster and better, and to help you to answer more fundamental and more challenging questions. We do this by providing cutting-edge detectors that enable better and faster insights for your science. So, starting today, we will support you also in managing your data and simplify collaboration. In a world where we are faced with major challenges that we can only solve together, like climate change, for example, we at DECTRIS want to contribute to strengthen collaboration in science, and we want to simplify your research. We have spoken to many of you who are here in this room today and to many of your colleagues, and we have learned that a big pain point is the analysis and the collaborative work on the massive data that our and other detectors produce. Today we are proud to introduce DECTRIS Cloud, a solution designed to allow even faster exchange of data between researchers, and a solution that enables collaborative work on the data from your experiments. DECTRIS Cloud is more than just a product or a service. It's a leap forward for all the researchers that work hard every day to make new discoveries, to ensure a good life for future generations. And we're excited to show you now how DECTRIS Cloud can revolutionize your research.
Welcome everybody, and why we are here today. Matthias already mentioned it a little bit, is what drives us, but I want to give a bit about the history. Why we DECTRIS, which you know as a detector company, now launch DECTRIS Cloud. Our detectors really enabled you to push science forward and to get more insights into processes, into materials. And this is really what makes us proud. These detectors are large and these detectors are fast. And you have dealt or learned to deal with this amount of data. They produce a lot of data because they run fast, and so that you can study the processes. Our detectors are not the only ones. In tomography, this is even more. The data the tomography stations produce, they are exceeding this. And you have worked all together at the beamlines, at the facilities to manage this. And you have made incredible solutions to really work with this data. However, these solutions are not every time very practical for collaborations. So these nodes that you have built, or these clusters you have built at the facilities, they are not used all the time. And so we see that there is a potential. And as you know, the history of the detectors and the science is every time pushing boundaries. And we know from the past that it's continuing. Next generations of detectors will produce more, and it will not get easier to really work on this. We have seen today in the lecture of Andreas Schäfer in the morning that he wants to scan a whole mouse brain in a few days. And for this, it's definitely important to work faster, get more insights, but you get also more data, which you have to work with. And we have seen this, and we have talked to you every time when I deliver detectors, when we work with you, we have heard from you that you cannot use the full potential of these detectors, not from the start, and every time is really difficult. And then once you can work with it, you have the data, and the scientists working with the data get then the problem further, because it's not from the facility, but it's then pushed to the scientists which work with the detectors. And this is really what we have here. We have heard from you that it's difficult to struggle with this, and we like challenges at DECTRIS, and so this is why we have said we want to contribute here, that you can work, and not alone, because science is everything collaborative, together on the data, and we have created DECTRIS Cloud. And with this, I would like now to give to Max to show us how it looks.
Yeah, thank you, Matthias. Thank you, Stefan. Thank you for coming. It's really a great pleasure to introduce DECTRIS Cloud, to show you how it works, what it does, and what values it provides. Overall, it's a service to enable collaboration through instant access and seamless sharing of scientific data and software. So what is DECTRIS Cloud? It's an open collaboration platform for scientific data, in a nutshell. It provides data storage and archiving capabilities, analysis and processing capabilities. It's designed to simplify sharing and collaboration. It's built in fair and open access policies, and it's globally available. So again, it's an open collaboration platform for scientific data. On a very high level, it's built on a local data store, meaning data stays stored on the continent where it's being generated. It provides a central data access layer to users, regardless of where they are. It provides scalable compute cluster capabilities and a data and software repository, open to reuse software and data around the world. And all this is globally accessible through the web application app.dectris.cloud. Now, what is DECTRIS Cloud for synchrotrons? What you're here for? It's all of what I mentioned before, plus your connection of your detector or microscope at a facility to the DECTRIS Cloud through an encrypted, high-speed data transfer. So there are two fundamental components to this service. The first component is one that it's a fully managed infrastructure. There's no large one-time investments over the years. It's plannable and predictable. We provide the management of this infrastructure. The second component are modern data tools, Jupyter Hubs, environment management, data sharing, user management, experiment management. So it consists of two layers, infrastructure and tools. For synchrotrons, the design guidelines for us were to have a service for the most challenging data processing and analysis needs of modern synchrotron experiments. So we looked at where are you struggling at the moment and how can we help. The four key values it tries to provide are instant data availability, peak compute performance, open data access, and simple sharing and collaboration. And I will quickly explain for each of these four pillars how this works. Instant data availability. The service, DECTRIS Cloud, connects directly to the detector. We provide a high bandwidth internet connection to the synchrotron. We operate a dedicated network within the facility, and we provide what we call a hub, an uploading device that authenticates the beamer, encrypts the transfer, and gets data into the cloud at very high rates. All of this runs completely in parallel to your internal infrastructure. The service is designed so you do not have to turn off what you're currently doing. It's an add-on. And through the web interface, the beamer and staff can simply turn it on and off, depending on the user. So if you have a user that wants to use it, you can use it, or she can use it. If not, then not. By doing that, we can get data available in the cloud on a processing node in less than 3 seconds. For beam-licensed users, it means no waiting for data transfer, regardless where the user is, and users can immediately start the data analysis during the experiment. The second key value is open data access. All scientific data is managed through what we would call experiments. This can be raw data, metadata, auxiliary data, or results. And how this data is being managed is defined in our scientific data policy. This is a legal framework based on open and fair principles, and it has actually been written based on the Panos and Expanse recommendations. We have a copy of this at the booth. You can pick it up and read the full document if you feel like it. In a nutshell, we guarantee data accessibility for 5 years. Even if your subscription ends or you stop using DECTRIS Cloud, data remains accessible for users and public for 5 years. We enforce open access. 1 year after the experiment has concluded, data will be made publicly accessible by default. And again, it's multi-facility access. So regardless where it's generated, you have one access there. For beam-licensed users, this means it's guaranteed long-term data availability for use and reuse, and open science compatibility with funding schemes, for example, in the States or in Europe. Third pillar is peak compute performance. Any user of DECTRIS Cloud can provide software. This can be a developer, a facility, or a home institution, or a user that is preparing his next experiment. The user can do this over an interactive session, like a virtual machine, provide a Docker container or a Python environment. One of those ways. These environments can then be used for either automatic processing, so either starting a job through the web interface or through a custom API endpoint, where you can define your own pipelines. The other aspects are explorative analysis tools that can be run, like virtual machines for 3D analysis or Jupyter notebooks. And all of this is deployed on really highly scalable global compute cluster. We can provide up to 32 dedicated nodes per beamline. So think about it like your private beamline cluster. This runs on the newest GPU architectures and NVIDIA GPUs. Running this in the cloud has the advantage that it's more than 99% done on renewable energy sources, and again, doing it in the cloud allows us to save up to 70% of CO2 emissions compared to on-premise installations. For beam-licensed users, simple click-and-play access to modern high-performance compute environments, and it enables new, highly complex data analysis tasks. A sneak peek or some preliminary results of benchmarking we did. FastDP, standard MX pipeline, for example, we could run approximately 50% faster. Azimut integration, instead of running, this was a 16M integration, running it on 15 dedicated nodes, we could get the same throughput at a single node. So this is about 15 times more energy efficient. And for type tomography, having access to tens of GPUs at the same time drastically accelerates the time for user feedback. So having 1,800 reconstructions at the same time gets the feedback time from 19 hours to about 15 minutes after the last scan has concluded. The fourth pillar, and really the most important one, is simple sharing and collaboration. Any data or software or environment or job can directly be shared with any other user by adding this person as a collaborator. It's really a click of a button, no transferring, no reinstallation. The other pillar is the data and software repository that will go online in a few months. This will allow users to publish data and to publish software and make it reusable for anybody. And by doing that, for beam-licensed users, this facilitates sharing of data and software, really by the click of the button, and no data transfer, no software reinstallations. So to summarize this, instant data availability, immediate start of data analysis during the experiments, open data access, means long-term data availability for future reuse, peak compute performance, really enabling complex, new data analysis tasks on data, and simple sharing and collaboration. So seamless collaboration through instant sharing of data and tools. And by providing that, we believe that we can accelerate the scientific data value stream through collaboration. Summary, it's a public web platform That's freely accessible to all users. Anybody can register today and create an account. It's very open by design and it's vendor agnostic. It does not only work with DECTRIS camera, also with other detectors and microscopes. It's really designed for the facility users. Open access to data from all facilities. There will be free-based services for everybody to use, such as virtual machines, notebooks, regardless if you have a subscription or not. And it empowers users by reusing facility software from home. For synchrotrons, it enables peak experiments by providing fully managed infrastructure at predictable costs, so no large one-time investments. It's capable of handling petabytes of storage, and it has instant scalable high-performance compute capabilities. The service is available from Q4 this year, and depending on the facility and where you are, the delivery time is about 3 to 6 months. And with this, I will hand it to our first collaborator, Judith from Alban. Oh, no, sorry, oh God, sorry. What does it look like? An image says more than 1,000 words, right? So this is the login screen. You can register and log in. Sorry, Judith. The first thing you see is experiment management, where you can share data by simply adding collaborators. The moment a person is added, they get access to the data. There's file browsing capabilities, obviously, image viewing, where you can get a first look at image quality, for example. Logbook features to take notes during experiments. A live experiment status, so everybody that's linked to an active experiment can see what's currently happening, what the file upload status is, what the detector is doing. A session launcher where you can create virtual machines, and then also when you run virtual machines, you can do 3D interpretation, interactive analysis, high-performance processing. This all runs in the browser. There's no software that needs to be installed. You can actually see that at the booth, how this works. And if you need help, there's a help center here at the bottom where you can ask questions, give feedback, report bugs, because we know they are always there. And get in contact with us. And now, Judith. Sorry.
It's okay? Yeah? Okay, morning everyone. I'm Judith Janusz, people responsible of the microfocus beamline now under commissioning at our synchrotron. And that goes without saying, but I have never worked with for DECTRIS, but I have worked with DECTRIS actually. So I mean, this is a kind of win-to-win collaboration without any profit. So. DECTRIS came something like 9 months ago and asking to first implement DECTRIS Cloud in our facility. Our facility actually was good for them, and it was good for us to check which are the possibilities of using the cloud, any cloud actually, to store our data. These are our two MX facilities in which DECTRIS Cloud was installed. I'm going to start with the second one actually. The microfocus. No, not yet. Not yet. Talk about. These are my big Okay. So Shiny is now under commissioning, and so we have no users, so we could do some tests. It features an IDA 2 XE 9M, so it can run up to 550 Hertz, so it's fast enough in order to do some real good tests. And actually this is what we did. We first did the test at the beamline, and then we, as a second test, we did we implement DECTRIS Cloud at the we meaning DECTRIS and ALA in the operating beamline, the microfocus, the MX workhorse MX beamline that we have, which has been operating for more than 10 years, and we have more than 1,000 PDB entries in the database, etc. So we wanted to first test in a rapid, fast detector, and then implement it in a real beamline, operating beamline. So essentially, these are the results. Actually, the tests were done last really more than 1 year ago, and essentially, Netis came and installed in our VMware a DCU server for just to transfer to do the first tests from a real facility using our current IT services. Several the correction modes and data streaming and also both locations of the cloud were used, and essentially everything worked perfectly well. More than 90% of the theoretical bandwidth limit was achieved, and everything simply we ran very smooth. Of course, we used artificial beam images first because we had no beam at the time, but also even for the second operating beam line, simply because we don't want to mess with permissions. We wanted to simply to talk about data, the amount of data, not the real data in order to process it. Right. So after the first test with a non-operating beam line with a fast detector, then we came with an operating beam line, Sherlock. And actually, what happened, what we did is just used artificial images mimicking the images that were actually taken at the beam line. Right. So I mean, we didn't transfer the real images. We simply just copied and invented images with the same data, with the same amount of data, and transferred it in different positions of different locations in the world and with different modes. And so finally, we transferred more than 1 petabyte of data, and we transferred more than 11 million images that were the images that were produced at the beam line. So essentially, this ran in since February until now, and the conclusions actually to finish is that local and cloud transfers and storage were performing equally well. So I mean, we have a very nice IT HPC center, and our HPC center works well. The DECTRIS cloud works equally well. Also, no latency times were observed due to the access. It's true that we could tailor a little bit our needs, the service according to our needs, and it's true that once we had the DECTRIS cloud installed at the beam line, our human resources were simply not needed. That was working. The operation was seamless, and it was the data were transferred to the cloud. If we wanted to access the data, we could. That's it. And essentially that's it. That's our experience.
Thank you, Julian. I'll just wrap this up with a bit of technical data. I'm showing exactly the results of these uploading tests. So what you see here is an IGA 2XE9M running 500 Hz with artificial images at the same file size. So you can see here, is this pointer work? Let's try. Yes, there we go. The data rates, okay, this is good, I'll leave this. You can see the data getting into the hub at about 70 gigabits, and then here on the other side you see it getting into the cloud. This was a burst acquisition, and what Judith mentioned, we also did a long-term capability test where over the weekend we uploaded at on a 100 gigabit link 1.2 petabytes in 72 hours at an average bandwidth of 92 gigabits. So this really worked tremendously well. And with this, I'll pass it to Thomas.
Right, so my name is Thomas Urski. I work at Max4, and I will tell you a little bit about the tests of the cloud we've been doing at Max4. I'm working with a VMware called Micromax, situated at Max4. It's a VMware for serial global timers of experiments. They're also for high throughput cryo-MX, though we don't have that in operation yet at Micromax. We have a second MX beam line called Biomax, which is the high throughput MX workhorse. It's a micro-focusing beam line, high flux with a multi-layer monochromator, short pulses with the help of a chopper, and it's in user operation since this spring. Different sample delivery systems for serial crystallography, and we also have these two detectors. So we built this sample or detector table to be able to switch rapidly between an integrating and a photon counting detector. What you see here on the left is what we have presently, a Jungfrau 9M and an Eiger 9M. The Jungfrau 9M is okay. It's a game. Anyway, the Jungfrau 9M is on loan from PSI. It's not our detector. What it's doing. But anyway, that is to show a little bit that we can produce a lot of data and are interested in see what we can do with the data. So this is a little bit of the test that we did, and actually, thank you. We did some tests at Micromax, and these were actually less exhaustive than what Judith and colleagues did at Alba. One of the things, we did a test together with Max, Lumila and Pascal in June, and it was basically to see if it works, hooking up the beam onto the cloud. We could see that the images from our Eiger detector appeared in the cloud after 2 seconds. We're ready in the computing nodes after less than 3 seconds. We collected some fixed target serial crystallography tests. We have a lot of crystals on a small chip and scanning this through the X-ray beam. It was not our standard data collection parameter, so we just wanted to review some data and see if this worked. And well, to the right is some timing results from processing with different yeah, so a different amount of computing resources, and I think the number here is not very important. It was basically just to see that it worked, and it worked well. I mean, eventually, if we have this for users, obviously we need to have to see that they are getting fast data analysis, easy access, and a good user experience for access to the data. But this was just the first test for us. We'll do more tests. And I wrote down a little bit about my thoughts about this. It gives this, I mean, Max has said a lot of this, it gives us this additional resources for the users, these additional resources when needed, which should be easier with a large computing center than our on-site smaller resources. I mean, for the users, obviously, they would have the data from different facilities, possibly. That would make it, they would have their setup, analysis set up, and all the data at one place. It would be easier to share different analysis scripts and so on with others, but also that they are available to you. It should be less work for us for maintaining software and possibly hardware, or obviously hardware also, but that's not for us at the D9 as it is. From our horizon would be more of the software. And obviously overall it should be more efficient use of resources. There are other aspects like costs. Obviously this is an extra service for users, so maybe it warrants an extra cost, but overall if it is a more efficient resources, obviously it should potentially lower costs. We're not presently planning to do this for this fast online feedback we do with our serial crystallography time solved experiments. There are a lot of questions. Many of them have been answered by Max and colleagues with input from people from different facilities, but I think for me and my colleagues, it's something that we need to think a little bit more about the details, how this would work, what resources we would have on site in the cloud. And also just at max 4 for the facility. So I think we also need to discuss this between beamlines and with other groups. What are the positive and difficult aspects of this, or what it can be used for, etc. I think that's all I wanted to say.
Yeah, thank you, Thomas. And thank you, Philip, again, for the contributions. We're doing the third guest contribution based on an experiment that we did at PX1. It's a tensor tomography strong X-ray scattering experiment, where the science case was pushed by Mario Levy, and the methods, the instrumentation support was done by Mei Tian. They are both not here, so I will present this on their behalf. I hope I will do that in an adequate manner. So again, this is really was quite a big collaboration with the main leads here were with Marianne Levy and Tony Tenzer from EPFL and PSI, and Mei Tian and Philip. Philip is actually here today, and a lot of other people. I mean, this experiment like this cannot be done by 4 people. This is really big effort. So really big thanks to everybody involved. PX1 is originally designed to be a max beamline. But in the recent years, and especially through the installation of a SmartGon scanning stage, they have started to also do tensor tomography, diffraction, SmartGon scattering experiments at their end station. And basically the idea is that you take a material sample and you record diffraction in 3 dimensions, and then if you do things right and you have the right software running, you end up with this 7-dimensional information. So at 3 dimensions in real space, you get a texture vector with 3 dimensions and intensity. So there's a lot of information, a lot of data that needs to be crunched. And the science case was to look at these osteon formations in cortical bone. Again, here the idea is that the nanostructure in these osteons gives insights into the mechanical properties. So one has to measure the structural arrangements in 3 dimensions to understand how this then all plays together at the end in a real bone sample. And this is done, for example, with small angle scattering X-ray tensor tomography. So basically, they got one of these osteon microbillion samples. It's about 250 microns in diameter, 500 microns in width, so you have an idea of the order of magnitude. And what you do is you scan 280 projections with a 5 micrometer beam, you tilt the sample to 5 different angles, so you end up with about 4 million diffraction patterns to get one 3D tensor tomography volume. And this is when you've done the processing, you've done the reconstruction, the assembly, and also the visualization, what you end up with. And basically at each of these voxel points, you get, again, a texture mapper of the osteon alignment and the degree of alignment. In this case, it's quite nice how you can see the Parisian canal here, where you do not have that. Quite illustrative. And in this case, this was an experiment done with an IGES X16M running at 100 Hz, produced about 6-7 gigabits after compression. Also here data was directly uploaded into the clouds, into the storage, and there we already had basically all the services needed to do the full data processing analysis. We had virtual machines for image masking, calibrations, image analysis and alignment, so by PyFay, for example. We then had real-time processing running that would do the Azimut integration online at, again, 100 images per second, 16M on a single node. And also the 2D analysis, so really making these 2D projections, so interactive plotting of distributed notebooks. And all of this worked really quite well. We had moved a lot of people on site, remotely connecting, using this together to get to the result. We had about 50 terabytes of real experiment data in 4 days. And again, the entire processing analysis pipeline really worked quite well. Good. Maybe to close this up a little bit, what's next? This is a start, and people here that have done software development know it never ends. So what comes next? We have installed and tested this with multiple facilities around the world. We have collaborators in Europe, the States, and in the next months we will connect a few more sites in the States and Japan. So we are really trying to get this on an international global scale and see how this collaboration effect really comes in and increases the scientific impact of people. In terms of development, as said, the service will be available in the next quarter of this year, Q4. We are currently working on making the processing capabilities and automated data processing capabilities production ready. The next things will be Jupyter notebooks, getting the software repository for sharing of software online, and then also at some point provide proprietary data handling policy, as quite a few industrial users have expressed interest. And by Q2 next year, we want to have the open data portal ready. However, this is a service for collaboration, and it's also built on collaboration. So it actually is really a community development. Anybody can go to roadmap.dectris.cloud and see what we are actually working on. Everybody can suggest new features, vote and prioritize features, see what we work on, give feedback, leave comments, give improvements, suggestions, or see the release date when it will get to production stage. So it's really a service that allows people to shape it. So you all have the chance to shape DECTRIS Cloud for what you think it will be best for you and the users. And again, this has been a really big collaboration between many people. It's really too many to note here. To point out Judith at Alba, Max Ford, Thomas, and the BMAN teams, PSI, Berkeley Lab, ISRF, Angie with the reading of the policy, AMSTO for tachography reconstructions, global facing for MX workflows, EPFL, Marion, the experiment we showed, Benedict and Björn from TypeI for type reconstructions. The ESNet backbone, John has a lot of support. Eugene from CCP4 and also Max from Scikit, and obviously the 3 hyperscalers that we work with. So really a big thank you to all of the people that have helped us and supported us. It's really a big collaboration effort. So to close it off, I'll hand it to Stefan.
Thank you, Max. Thank you, everybody, for staying here today with us and coming to the lunchtime seminar. Max already thanked everybody here, and I would like to thank also Max, the whole team developing, but also Judith and Thomas for being here now. So now it is up to you. We are living from the feedback, we're living from this, what is there, and as Max has shown, there is the possibility to give us feedback, to contribute, and you can already start with logging it, trying it out, testing it, and seeing also which features come up. If you want to know more, we will have a more presentation tomorrow at lunchtime. You can come to the booth and see it. You can see how this works and also interact already. And for now, we close this up now, and then we have a T-shirt waiting now at the booth. And if you want to find the booth, we are in the exhibition area, really in the corner, on the side in the back. But you will find us there, and we are very happy to welcome you there and explain you more about it. Thank you for coming, and have a great day.